Hello, my name is Nicolás Sucari. The question I will answer today is number 5, which is, how can we define endogeneity? What are the main sources of this problem and what are its consequences on the OLS estimator in the context of the linear regression model? Detail the different methods allowing to obtain reliable estimates in such a context and give a specific example in finals. Endogeneity occurs when there is a correlation between the explanatory variables and the error term in a regression. It leads to biased and inconsistent parameters estimates that make reliable inference virtually impossible. Let's have a look at the linear regression framework. For example, the following equation, where y is the dependent variable, the x are explanatory variables, u is the unobservable random error, and betas are constant parameters to be estimated. The key assumptions needed for OLS to produce consistent estimates of the parameters are the following. So once we have the assumptions for OLS, we should focus in number 4. The violation of this assumption is the main cause of inference problems. Let's see the causes of endogeneity: omitted variables, simultaneity, and measurement error. Each of these three maintains the first three assumptions of OLS, but as I said before, a violation to number 4 will introduce the problem of endogeneity. So now let's look at omitted variables. Omitted variables refer to those variables that should be included in the vector of explanatory variables, but for some reasons are not. This problem is present in many cases in corporate finance, when CEOs or corporations are being evaluated. In the case of executives, for example, their compensation depends on their abilities, which are difficult to quantify and more difficult to observe. The inability to observe these determinants means that instead of appearing among explanatory variable x, these omitted variables appear in the error term. If these omitted variables are uncorrelated with the included explanatory variables, then there is no problem for inference. The estimated coefficients are consistent and, under the stronger assumption of zero conditional mean, unbiased. If the two sets of variables are correlated, then there is an endogeneity problem that causes inference to break down. So now let's go to the second cause of endogeneity: simultaneity. Simultaneity bias occurs when y and one or more x are determined, and it can be argued either that x causes y or that y causes x. The dependent and the independent variable are correlated, meaning that they can cause each other. So now, for example, let's have the key nation consumption function, where CT denotes a country's real per capita consumption and YT is real per capita income. We want to interpret the coefficient V2 as the marginal propensity to consume. However, the aggregate income is not exogenously given, as it will be determined by the following formula, where IT is real per capita investment. Investment is exogenous because it is not correlated to the error term. In contrast, both consumption and income are endogenous variables, which are simultaneously determined in the model. Consequently, the OLS estimator for beta 2 will be biased and inconsistent. Measurement error is another cause of endogeneity. Most empirical studies in corporate finance use proxies for unobservable or difficult to quantify variables. Any discrepancy between the true variable of interest and the proxy leads to measurement error. When variables are measured imperfectly, the measurement error becomes part of the regression error. The statistical implications of measurement error in the dependent variable are similar to those of an omitted variable. The estimators will be biased but inconsistent. So now, in order to fix endogeneity, we're going to see the instrument variables. The standard remedy for endogeneity is finding an instrument for the endogenous regressor. An instrument is a variable that satisfies two conditions that we refer to as the relevance and the exogenous conditions. Exogeneity refers to the error term and the instrument variable to be uncorrelated. The relevance refers to the endogenous variable and the instrument variable to be somehow correlated. If there is an instrument variable that satisfies both the exogenous and relevance conditions, then we can use this instrument to substitute the endogenous variable. There will be a new estimation for beta with the instrument variable. So finding instruments is not always so simple. When we drop the assumption of the correlation between the error term and the endogenous variable, we introduce a problem of endogeneity. In order to solve it, we need to incorporate a new assumption, but it is also in the form of the correlation between the new instrument variable and the error term. However, as the error term it is unobservable, we cannot identify which of the two assumptions is better. And to estimate the error term, we need a consistent estimator of beta first. The last concept I would like to introduce is the two-stage least squared. Given a set of instruments, the question is how to use them to consistently estimate the parameters. The two-stage least squared removes the portion of variance in the variable x that correlates with the error term. To do so, the 2SLS estimator relies on the instrumental variables, which are exogenous regressors of the problematic variable. As instrumental variables are uncorrelated with the error term, they can be used in a first estimation stage to obtain predicted values of the endogenous variable. These predicted values can then be used in a second stage to predict the dependent variable. So my analysis about endogeneity has come to an end, but thank you very much and goodbye.